At Cold Spring Harbor Laboratory in New York, Jerry Yin, a molecular biologist, and Tim Tully, a behavior geneticist, have taken the study of fruit flies from body structure to behavior, trying to understand one of science's great mysteries, memory.
Memories are so personal. They really are a huge component of our self-identity. You know, the memories that we carry around, the memories of all sorts of things really, to a large degree, constitute us.
But how do you test the memory of a fly? That's Tim Tully's job. He's the Pavlov of flies. Using mild discomforting electric shocks paired with distinctive odors, he teaches flies to run a maze.
And I've trapped them in there, in their training chamber. I'm going to apply vacuum to draw air through it and hook the electric current up to the floor of the training chamber. And now to begin training, I'm going to put one odor on the end of the training tube. This is octanol that smells a little bit like licorice. And I'm going to turn the current on. So now air is being drawn through the top of this chamber, out the bottom, and through the training chamber. And the flies are being shocked for 1 second every 5 seconds for a total of 60 seconds of training. After 45 seconds, we're going to put a second odorant on the training chamber, but this time don't turn the shock on. So they've been shocked in the presence of octanol, not shocked in the presence of methylcyclohexanol, which smells like my tennis shoes in July.
The flies are lowered in an elevator to a tea maze. On the left, the shocking licorice smell. On the right, the safe, smelly sneakers. Most of the flies avoid the smell associated with shock. With 10 training sessions like this, an average fly will create a long-term memory to avoid licorice smells. With the test in place, all Tully needed were the right subjects. And that was Jerry Yin's job. Before coming to Cold Spring Harbor, he had isolated the gene most likely involved in long-term memory formation in flies. It's called the CREB gene. It seemed to produce two products, the CREB on switch, which increased gene activity, and the CREB off switch, which suppressed it. To test the gene, Yin genetically engineered flies that would only make the CREB off switch. When Tully tried to train them in the maze, the results were shocking.
We saw that the appearance of long-term memory itself was disrupted. No other aspect of the fly was affected. It still smelled the odors normally. It still sensed and escaped from the shock normally. It just couldn't form a long-term memory of that event.
The genetically altered fly could not be trained.
This is a very encouraging experiment, but it's not absolute proof, because you might be disrupting this process in a very indirect sort of way.
Intrigued, Tully and Yin next tested flies that only made the CREB on switch.
They actually had enhanced long-term memory. They formed long-term memory after only one practice session, when a normal fly requires 10 practice sessions to form a long-term memory. So what expressing the CREB on switch basically did is it created a fly with the functional equivalent of a photographic memory. Since we use odors and shock, I guess we would have to call it an odorgraphic memory.
Odorgraphic flies? A new flea circus? Perhaps much more. With the shared genes in flies and humans, is the manipulation of human memory far behind?
I think the speculation is both exciting and scary, because certainly what we're talking about here is that memory is a biological process that we can tinker with.
Control over memory raises scary specters. But imagine a drug based on Yin and Tully's work that helps those with deteriorating memories, like people with Alzheimer's disease.
If we can turn the CREB switch on, and essentially increase the gain in long-term memory formation, then Alzheimer's patients that have trouble consolidating short-term memory into long-term memory will get more into long-term memory, and they won't suffer the same kinds of memory losses that are associated with the progression of the disease.
But could there ever be a time when it is better to forget? Tully imagines a long-term memory suppressor as a morning-after pill for traumatic events.
Even though one traumatic event, can be consolidated into long-term memory, it still takes time after the event to accomplish the consolidation. So if a long-term memory suppressor can be administered in the hospital after the trauma within that critical period of time when long-term memory is being formed, then you can block the formation of that very emotional traumatic memory.
Strange and exciting possibilities, as revealed by the well-trained fly. They sound like science fiction. Does this mean all we are giant flies?
We are by no means big flies. We are very, very different from flies. And yet, the machinery that creates us has a lot in common with the machinery that builds a fly. So we're at really the opening of a time when we're just beginning to understand how these genes work in any organism.
Our shared genes are a map to the future that is only beginning to unfold.